Okay, I think we are a few minutes late, but we'll try to rush through this presentation. Thank you for being here. My name is Perver Baran, and today Payam is joining me to present this small talk. I would like to also acknowledge our two co-authors that are not here today, Shahab Nazari Adli and Duarte Moraes. So you heard actually what IVE is, what immersive virtual environment is, and in next 15 or 20 minutes, we are going to talk about how IVE could be actually coupled with GIS to complement human perception data. So we are going to present actually 3 projects to exemplify this coupling. And the first project looks to how to use IVE in mapping perceived safety in a park environment. The second project will look to examining restorative potential of urban green spaces. And the third project is going to look to individuals' preferences of landscape features in farmscapes. So a little bit information about the first project. Basically, I will talk about the more traditional kind of presentation, looking to background, objectives, methods, results, and conclusions. In general, we know that parks have opportunities or provide enormous opportunities for leisure time and utilitarian physical activity. However, park use diminishes, or visitors actually or residents do not visit parks if they perceive danger, if they perceive fearful in particular environments. Literature tells us that these feelings of fear of danger are basically influenced by spatial enclosure, which in park settings basically are created or is created through arrangement of vegetation as well as vegetation type along pathways. So the overall objectives of this project were to examine how spatial enclosure relates to perception of safety utilizing non-manipulated representation of park settings through IVE. And second, we wanted to explore method to collect this information to spatially map safety perception patterns within parks. So on this slide, you see the park setting. How many of you know Fletcher Park? Okay, with a few. So this is Fletcher Park, a small neighborhood park in Raleigh. The area that is in red actually is the study area, which is kind of a unit that is visually accessible from most of the points as we walk around. So within this park, we basically walked and inventoried different areas along the path and selected these 8 locations shown in red that represented different enclosure conditions. And this is how we experience basically. And enclosure is defined mainly through locomotive permeability, if we are able to walk around, and visual permeability, how much we can see through the environment. Then using regular DSL camera, which was mounted on robotic controller, we collected images from these 8 sites. So here we see 3 different conditions. On the left, we have area that is high in openness, so low in enclosure, then medium enclosure and high enclosure space. We wanted to develop method actually to quantify what we saw, just to ensure that actually our kind of intuition to distinguish these spaces in space is also quantifiable. So looking to permeability theory, which says that enclosure actually is identified by locomotive permeability, how much space I do have around me to walk in case of danger to escape, and through visual permeability, which indicates how much I can see in my surroundings. So we developed 2 measures. One is visible area. This is hypothetical circle or buffer around location. And the second is visible arc, which is proportion of this radius along this area. So as you see, the area reduces as well as the proportion of this visible arc is reduced as we move from low enclosed location through high enclosed location. And here you see examples of these locations. So a little bit technical aspects of how we develop the immersive virtual environments. Basically, we capture the images, we can set up different resolution. In our case, we captured 54 images for each site. Then these images were stitched together to create a panoramic image or panoramic scene. Then this was actually was translated through image or through a process known as cube mapping. Basically, it takes the image and projects into a cube surface of six sides of the cube, which finally are wrapped to represent a space in which person can experience. Basically, imagine that a user or the viewer basically is within this space, and the sides of this cube are projected on the display, so that the person feels like immersed in that particular environment. Here are the 8 stimuli. These are the most open locations, and these are the most enclosed locations. You can see actually when we have the panorama, you do not have a sense that these are very enclosed locations, but really they are very enclosed. When you are in these spaces, it's a little bit frightening. You do not see almost anything. The panorama doesn't show that, but when we are in this space, and here hopefully this video will work. So this is actually what user sees. And certainly this is in 360 degree. This is still a little bit reduced view. So this is the most open location. It stopped a little bit, I think, rendering. I don't know. There is something with the software doesn't work. Okay, I will skip this. This seems like it doesn't move as smooth, but basically the locations were experienced through this sequence. So how we conducted the study, basically we had 48 undergraduate students from Department of Park, Recreation, and Tourism Management. They experienced each image, and each image was rated, or each environment then was rated for perceived safety. They responded to one question on how safe you would feel to walk alone in the environment during the day on a 5-point scale. And after rating, they actually were asked to indicate reasons based on what they base their judgments. Because these are not manipulated environments, there are many variables, it's quite complex, so we wanted to know how they think about this space. Very quickly about the results. Here we see perceived safety across 8 locations. The least safe locations were the high enclosed locations. The most safe locations were the low enclosed locations, or the locations that provide wide opportunity for seeing around and moving around. These are very open locations. And when we did statistical analysis, we were able to reveal that actually there was statistical significance difference between high enclosed locations and between all remaining locations that were basically low and medium enclosure. But there was no difference between low enclosed and medium enclosure locations. This is good, basically, unless the environments are extremely closed, still they are not perceived as very unsafe. Then we look to the gender differences. As expected, females are feel less safe than males. And the statistical difference indicated that actually this difference now didn't exist in very open locations or low enclosure locations. The difference actually was very prominent in high enclosed and medium enclosed locations. We asked participants to indicate the features, attributes based on what they evaluate the environments as safe or unsafe. We did some correlation analysis between their perceptions and number of times particular feature was mentioned. And basically, open, empty, see everything, and presence of people were mentioned as attributes that contributed to perceived safety, while negatively associated features were enclosed, cannot see, trees, bushes, off-road, no pathways, no pavement, no people. Then, using average perceived safety scores per location, we just did very simple interpolation in GIS using inverse distance weighted with barriers tool in ArcMap to map perceived safety. And we developed 2 maps, one for males and one for females. And as you can see, the park actually is predominantly perceived as quite relatively safe space, except the locations around these points that were a little bit clustered around dense vegetation. And I just realized that my mouse doesn't show on the screen. I'm seeing my mouse movement on my screen. I'm thinking that you are able to follow. I think for time, I'm going to move through these conclusions very quickly. I will move on to the second project. In this one, we used actually manipulated images now. So we capture images, manipulated those, and we examined the restorative potential of urban green spaces. A little bit background, nature in various forms is shown actually to be very beneficial for human health. Nature, contact with nature improves basically mood, cognitive recovery, creativity, stress recovery, and they are good for restoration in general, mental restoration. However, research tells us that this restorative potential of space, of landscape, depends on configuration and contributing elements. And now enclosed setting perceived to have highest perceived restoration potentials. So you can see now there is a little bit conflict here. Before we said most enclosed spaces are most fearful, and now literature tells us that most enclosed spaces, when we deal with vegetation, are potentially most restorative because people are actually, this type of buffer provides some type of sensory separation from the surrounding. If you think there is noise or chaos around, if you have a little bit buffer with vegetation, you may feel more being away from this everyday chaos and then feel a little bit restored. So the main purpose of this project was to explore the restorative potential of spaces. Basically, we wanted, if you look to specific aims, we wanted to examine the main and interaction effects of density and framing, and I will talk what these concepts mean in the context, on perceived restorativeness and perceived safety, and to assess basically if the magnitude and direction of these relationships are same or different between different contexts, if we have this in urban plaza or in a park. And third, to see if actually perceived safety mediates this role of connection between the environmental features that we are examining as well as perceived restoration. For this project, our starting points were two real locations. Again, Fletcher Park was one of those with open field, and on the left we had Fayetteville Street Plaza. This is just 2 blocks actually from here. Convention Center is on the left side, on the left image. So we again captured these images. The difference here was that after we stitched the images, they were manipulated, and Payam manipulated these images in a way that integrated real representations of vegetation to create these different arrangements. Then the process was basically same. The image was rewrapped, but we had a development stage in which, again, Payam did some programming to automatize the process, basically. And I will talk about what was done in this process. And then these were displayed to research subjects to respond to certain questions. So our variations in this small square involved changes of density of trees and framing, which framing means number of sides. This space is enclosed. So one-sided, two-sided L-shape, and then three-sided, four-sided at the bottom. And then all these three framing conditions varied also by density of trees. For each segment, we increased the density from 1, 3 to 6 trees. And all this was replicated across urban, or across plaza and park setting. In here, we didn't use basically GIS really to measure this enclosure, but from our previous study, we used the same concepts of visual permeability to develop these variations. Certainly, the area is equivalent, so the area of locomotive basically permeability remained constant. And here we see a number of stimuli. The upper left is urban context, low density, one-sided enclosure, and couple of perspectives. And then the bottom one is urban context, medium density. So there are 3 trees on each side, but there are only 2 sides in L shape. And a few other images. These are very dense environments. By the way, in the NC State's booth, these demonstrations are live, so you can stop by and view those with IV environments. And then these are similar designs that were now integrated within park setting. And let's see if this will work. Maybe no. Let's just go here. Where? Oh, I see that. Okay. So we are working with 2 screens. Okay. Thanks. So we instructed actually participants just to rotate around to experience. It was interesting. Some students recognized the location and some didn't, and some they didn't actually wanted to move around and look behind the trees. This is 2-dimensional image in a sense. It's not 3-dimensional, but it was so real that was very, very successful replication. Okay, so let's go back to, okay, now how I go back? Okay, you need to move back now to this screen. No, I'm not able to see this. Okay.
You closed everything.
No, I didn't close. Now it was going to come back. Okay. So in this experiment, we had 90 undergraduate students. Then students were basically assigned randomly to one of the groups based on based on density. So one group only looked to low density environments, second looked to the medium density environment, the third group looked to high density environments, and these were replicated for urban and parks. So every person experienced 6 settings. So each participant, this was the programming part, each participant viewed this environment for 40 seconds. Then at the end of the 40 seconds, statements that they're supposed to rate these images on appeared on the screen. They were transparent, so the person was able still to move around and look at the environment and then respond to the statements. One was, again, perceived safety. How safe would you feel to walk in this space? And there were 6 other statements that actually evaluated perceived safety. We used perceived safety restoratively scale that looked to being away, fascination, and coherence. These are dimensions that are shown to actually represent the perceived restorativeness. And I will move on through the statements. So we found there are certain differences. Basically, framing is important variable in perceived restoration. As framing increases, restoration increases. However, we found significant interaction effects basically between the context and framing. In urban environment, framing influences perceived safety, but if we include this in park environment, didn't influence, which is interesting finding because for restorative, this is for restorativeness, because if we are not able to create big parks in urban settings, then at least small manipulations with a little bit trees providing certain enclosures, these can actually enhance the quality of environment for experiencing person to feel more restored. And spatial framing was negatively associated with perceived safety, and we are currently analyzing actually the data in more detail. So that's all, and now Payam is going to talk about the 3rd study.
So in this 3rd study, we wanted to go beyond comparison between environments. We wanted to know exactly what people care in each environment. Sometimes in research questions, it's very important. You want to know what elements of the landscape contribute to those perceptions. So this is specific study looked at the components that are preferred for tourism and agritourism. And I also wanted to know if the IV is a good tool for assessing perceptions and in terms of object identifying visual research. So the same as before, our colleague at Park Recreation Tourism Management took some images from farmscapes, systematically sampled through NC State, through North Carolina, and the same as previous procedure that described, they were all stitched and then put into Oculus. So this time we used a method developed at Center, with our colleagues developed at Center, that basically ties the head the head movement and head tracking sensor inside Oculus to a crosshair in the, within the environment. So people can use the joystick to select what they like in the environment. So the question was, please select 5 components of the landscape that you like the most. So how did we use this data? So I can briefly talk about the procedure. So you can see that the sensor inside the Oculus can detect 3 coordinates, which basically called yaw, pitch, and roll. And these coordinates can also be mapped into the cube faces that described before in the environment. So basically, wherever in this immersive environment they select, we can identify where exactly they selected in that picture. And then we can definitely use it through GIS to map it onto the picture, onto the horizontal stripe that all these facets are stitched together. So you can see I removed the top and bottom because people didn't basically select those. But this is left, front, right, and back facets of the environment. So this shows the distribution of the points and selections. So the different colors denote different orders of selection. In this study, we didn't specifically ask people which ones do you like best. So your first answer is your best answer. But we collected the order. That would be a very interesting future study that you ask people, for instance, select based on your preference in terms of order. And then we use simple kernel density to interpolate those points and to identify as heat maps where people are mostly interested in those landscapes. And then we had 6 different landscapes, and they gave us very nice results about the components of the landscape that farm owners can use in terms of promoting tourism in their landscapes.
Okay, thanks, Payam. And a little bit just overall implications and opportunities. Definitely we think that all this method provide insights basically for urban planners and designers as well as for managing open spaces. Definitely similar approaches could be used to evaluate other open spaces such as streets, trails, public squares. Certainly the approach provides opportunities to provide basically endless manipulation of environment to test the impact of various design elements on perceptions. We can talk about preferences, we can talk about attitudes, we can talk about, again, safety perception, restorativeness. It's very useful, particularly if you think about these alternative manipulations, to consider this as part of a design or planning process where we evaluate alternative designs, alternative scenarios. And certainly this is also a wonderful tool for public participation, basically, and engagement. Particularly the feature marking tool is very useful. You may ask people to show, let's say, barriers for walking in environment. And if you couple this and aggregate this data, then you can develop heat maps of the environments that actually are features of the environment that are barriers for walking. And similarly, there is also another work that asks people to rate, actually, to rank images. We didn't show any application here, but basically if you have 2 environments, you can rank for your preference, let's say. There is also application in which colleague of ours integrated sound into this and how sound actually changes our perceptions, our experiences of space. So it seems like we feel that this is a field that is providing great opportunities for research and understanding how humans experience space and how they feel about the space. Thank you for your attention, and we'll take any questions.
First off, let's give them I speak for everyone to say that it's really awesome that you can try to do science and also improve the quality of people's lives. So that's amazing.
Thanks.
Are there any questions?
And I realize some faces here that already tried Oculus Rift, so I invite you to stop by at NC State's booth and try this for yourself. It's amazing, actually, once you put these goggles, it feels like you are in a different world. Yes?
Have you looked into the contributions for environmental design principles for any of the park designs?
Yes, I'm very, by background, my training is in architecture and urban planning, and I've done a little bit crime analysis, so yes, I am familiar with that. And actually, some of these principles are coupled with crime prevention through environmental design, defensible space theory. Basically, visibility is one of the most important notions, surveillance it's very important notion. So for the second study, we've found that enclosure, the most enclosed location in park, was perceived as least safe. But the same environment was not perceived as least safe in urban context. And we feel like having the buildings and having windows, people looking to, like eye on the streets, Notion, Jacobs, if you are familiar with, all this contributes actually to having high visibility and comfort for people that are experiencing these spaces, and these spaces that do not feel very frightened. But I think there is potential to test a number of principles from crime prevention to environmental design, how really they work. Usually most of these studies are done, or there is potential that you take people to real sites and ask them what they feel, but we know how expensive that's and how much effort may need to go into that. So in this case, you take actually the park and you bring to people, in a sense, or which environment we are interested in. So there is potential to do that. Thanks. Any other questions? Good. Thank you.